So, good day everyone. So we are now at analytic geometry. So what is analytic geometry? Analytic geometry is a study of geometry using a coordinate system. So courtesy to René Descartes, which is the founder of analytic geometry. But in this video, we will focus on the distance formula between 2 points in a Cartesian coordinate plane. But before we proceed, what is distance formula? Distance formula is used to calculate the distance or the distance between 2 points. So let's take a quick look to our Cartesian coordinate plane. Our Cartesian coordinate plane composed of 4 quadrants. We have the first quadrant, which has positive and positive coordinates, and we have quadrant 2, which has a negative and positive coordinates, and quadrant 3, which has a negative and negative coordinates, and the fourth quadrant, which is a positive and negative coordinates. And these two intersecting lines, which are perpendicular to each other, is called the axis. And this horizontal lines is called the x-axis. And this vertical lines is called the y-axis. It's the y-axis. So moving on, where does formula came from? So let's say we have 2 points. Point A and point B. Point A is described by its coordinate x sub 1 and y sub 1, while point B is described by its coordinates x sub 2 and y sub 2. And using the distance formula, we need to calculate the distance between these 2 points. So this is D. And using the concept of Pythagorean theorem, if we extend this line here and then this line here, thus forming a right triangle here. And this point is now x sub 2 and y sub 1. So, given this distance is now y sub 2 minus y sub 1, while this distance here is given by x sub 2 minus x sub 1. So using the concept of Pythagorean theorem, which is the square of the hypotenuse is equal to the sum of the squares of the two sides. So we have d squared is equals to the quantity of x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. So by that, we have now the distance formula, which is d is equals to the square root of the quantity of x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. So now, this is our distance formula. Let's apply and use our distance formula. So let's say we have 2 points. So we have point A, point A, which is negative 2 and then positive 3, and we have point B, which is 2 and then positive 2. So In our point A, we have the x coordinate and the y coordinate. And in our point B, we also have a x coordinate and then the y coordinates. So, in these 2 points, we have to calculate the distance between these 2 points. So, how? We are now, by plugging it to our distance formula. Our distance formula is d is equals to the square root of the quantity of x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. But before we proceed to plugging it to our distance formula, we need to find first the value of these variables. So, our x sub 1 is equals to negative 2. Our x sub 2 is equals to positive 2. Our y sub 1 is equals to positive 3. Our y sub 2 is equals to positive 2. And upon knowing the values of the variables, our variables, we're going now to solve it and to plug it to our distance formula. To our distance formula. So we have d AB is equals to the square root of the value of x sub 2, which is 2, and then copy the sign, and then the x sub 1, which is negative 2, squared, plus the sign, and then our y sub 2, which is positive 2, and then copy again the sign, and then our y sub 1, which is positive 3, then squared. Then proceed. Again, copy the radical sign, and positive 2 minus negative 2 would become a positive 4 squared. And then copy again the positive sign, and then 2 minus 3 is equals to negative 1 squared. So again, copy the radical sign, and then 4, since it is in squared, then we have to multiply 4 by itself. So 4 times 4 is equals to 16. Positive 16 plus, and then negative 1 times negative 1 is positive 1. So again, copy the radical sign. 16 plus 1 is equals to 17. And then since 17 is not a perfect square, this is now our final answer. So the distance between point A and point B is equals to the square root of 17. So now, let's proceed to solve our problem. So we have a problem 1. Problem 1. Problem 1. What is the length of segment AB with endpoints A, negative 1 and 3, and point B, which is 3 and negative 3? So to get the visual understanding of this problem, we have to plot it to our Cartesian coordinate plane. So we have point A, which is negative 1. So since our x coordinate is negative, we have to move from the origin to the left. So let's count negative 1. And then our y coordinate is positive, so it means that we have to go upwards. So let's count 1, 2, 3. And now, where does this little dotted cross or intersect? It is in here. So now, we have point -1 and +3. Now, we have our point A. So now, let's plot the point B, which is +3. And +3, it means that we have to move from the origin to the right, since it is positive. So we have to count 1, 2, 3. And then our y coordinate is negative, so we have to move from the origin downwards. So let's count 1, 2, 3. And again, where does this little dotted cross? It is in here. So we have now our point B, which is the +3 and -3. Point B. And the problem is, what is the length? So we have to find the length or the distance between point A and point B. So again, we have to plug in it to our distance formula. Our distance formula is D is equals to the square root of the quantity of x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. So, AB, so the distance between AB is equals to the square root of our x sub 2 is equals to +3 minus our x sub 1 is equals to -1. And then squared plus our y sub 2 is -3. -3 minus our y sub 1 is equals to +3. Squared. So, let's proceed. Going to here. AB is equals to the square root. Copy the radical sign. So, 3 minus -1 is equals to 4. 4 squared. Copy the sign. And then -3 minus 3 is going to be -6 squared. And then, again, let's proceed. Copy again the radical sign. 4 times 4 is equals to 16. 16 plus -6 times -6 is equals to +36. So, AB is equals to the 0. Now, let's add 36 plus 16 is equals to 52. 52. Since 52 is not a perfect square, our answer is 52. So the distance between point A and point B is equals to the square root of 52. And now, let's proceed to our problem 2. Problem 2. Problem 2 is determine the distance between point P, which has the coordinates of +1 and 6, and point Q, which has the coordinates of +5 and +2. So, let's plot it to our Cartesian coordinate plane. So, first we have point P, 1 and 6. So, 1, and then y is positive, so going upwards. 1, 2, 3, 4, 5, 6. And then where does the intersect? Here. And then our point Q, +5. So 1, 2, 3, 4, 5. And then our y is +2. So these 2 points belongs to quadrant 1 because their coordinates are both positive x and +y. So point P and our point Q. And again, the problem is we have to find the distance between these 2 points. These 2 points. Okay? So again, we have to plug in the values of the x and y coordinates into our distance formula. Our distance formula is equals to the square root of the quantity of x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. And we have to get the value first of the variables. So x sub 2 is equals to positive 5. And our x sub 1 is equals to positive 1. Our y sub 2 is equals to positive 2. And our y sub 1 is equals to positive 6. So upon knowing the values of these variables, we will now going to proceed by plugging it to our distance formula. So, point PQ is equals to the square root of our x sub 2 is equals to 5 minus our x sub 1 is equals to positive 1 squared. Copy the sign. Our y sub 2 is equals to 2, positive 2, copy. And our y sub 1 is equals to positive 6 squared. Let's proceed. So, copy the radical sign. 5 minus 1 is equals to 4. And then squared, copy again the sign. And then 2 minus 6 is equals to negative 4. Negative 4 squared. So, PQ is equals to the square root of 4 times 4 is equals to 16. Plus, negative 4 times negative 4 is equals to positive 16 as well. So, PQ is equals to the square root of 16 plus 16 is equals to 32. Is 32 a perfect square? No. So, we have to think of a number that make it the simplest form. So, we have we have 2 and 16. So, we have 2 and 16. 2 and 16. And 16 is a perfect square. So, let's PQ is equals to the square root of 16 times 2. And PQ is equals to, since 16 is a perfect square, we have to 4, 16, the square root of 16 is 4, and then copy the radical sign and then proceed to copy the 2. So our answer for the distance of PQ, the line PQ is 4 square root of 2. So PQ is equals to the 4 square root of 2. So let's now proceed with our problem 3. Our problem 3 is, how apart are point X, 5 and 8, and point Y which has the coordinates of negative 2 and positive 5. So again, we have to plot it to our Cartesian coordinate plane. So we have the y-axis and then the x-axis. So our first point is the point x, which it has the x coordinates of positive 5. So 1, 2, 3, 4, 5. And the y coordinate, which is positive 8. So 1, 2, 3, 4, 5, 6, 7, 8. And they met at this point, x. And then 5, we have to label it. And our second point is the point y, which has the x coordinate of negative 2, so to the left, 1, negative 1, and negative 2, and then positive 5, so upwards. 1, 2, 3, 4, 5, so they met here. So again, we have to label it. So y, negative 2, and then positive 5. So again, the problem is how apart. So we are going to find the distance between these 2 points again. So by plugging, to find the distance between these 2 points, we have to use our distance formula. Our distance formula is equals to the square root of the quantity of x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. So first, we have to find the values of these variables. So x sub 1 is equals to positive 5. And our x sub 2 is equals to negative 2. Our y sub 1 is equals to positive 8. And our y sub 2 is equals to positive 5. So upon knowing the values of these variables and to have a visual understanding of this, we have now to plug in our these variables to our distance formula. So let's use this one. So we are looking for the distance between point x and point y. So x, y is equals to the square root of our x variable, our x square sub 2 is equals to negative 2 minus our x sub 1 is equals to positive 5 squared. Again, copy the sign, and our y sub 2 is equals to positive 5 and minus, copy again the sign, our y sub 1 is equals to positive 8 squared. So let's proceed. Copy again the radical sign. So negative 2 minus 5 is negative 7. So squared, copy the sign, plus, and then 5 minus 8 is equals to negative 3 squared. So copy again the radical sign. Negative 7 times negative 7 is equals to positive 49. Copy again the sign. Negative 3 times negative 3 is equals to positive 9. So x minus xy is equals to square root of 49 plus 9. 49 plus 9 is equals to 58. Is 58 a perfect square? No. So we have to think of a number which makes it the simplest form. So we have
So we get positive 29 and 2. 29 times 2 is equals to 58. But since 29 and 2 is not a perfect square, square root of 58 is still the answer.
So this is now our answer. This is the distance between point x and y. the distance between point X and Y is square root of 58. So, in conclusion, analytic geometry is a study of geometry using a Cartesian or coordinate system. So, distance formula is used to calculate the distance or the distance between 2 points. So, our Cartesian coordinate plane is composed of 4 quadrants. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And these two intersecting lines here is called the axis. And then this line is called the x-axis, while this one is called the y-axis. And then, to have the visual understanding of points, we have to plot it to our Cartesian coordinate plane. So, is equals to the d is equals to the square root of the quantity of x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. So, our distance, this is our distance formula. So, I hope that you've learned something in this video, and that would be all. Thank you.